Can everybody hear me? Excellent. How are you doing? Even better. Who of you has something to do with artificial intelligence? Not too many. Who of you has something to do with finance? Even more. This is surprising. So if I would have placed the bet, I would have bet the other way around. So today my talk will be about the combination of artificial intelligence and finance and what AI might do to finance. My name is Yves. I'm founder and managing partner of the Python Quants. I'm really happy to be here in Hyderabad at the first PyConf. And I'm really thankful for the organizers for having me here. Great organization, wonderful. So really, really great to be here. Thank you very much. Just from this week on Friday, a little quote. You read it more and more often, no matter actually what kind of publication you have a look at. So many companies are these days talking about AI first. Google in particular. So they had a big announcement. And here is one of the quotes that the CEO of Google made there. He said that as an AI first company, this is a unique moment in time for Google, and I think not only for Google in this regard, to combine hardware, software, and artificial intelligence. It's radically rethinking how computing should work. Of course, he was, in this instance, referring mostly to home appliances and, in this regard, competing with the Apples of the world and so forth. But nevertheless, I think AI and what is happening in this field might influence almost any area that we can think of. I would compare it to the rise and the upcoming of the internet and the so-called web, www, where in the beginning people said, well, this is something new, something different, something separate, and there were the startups, many of them failed, people learned, and I think today the internet and the web is something that is in every company included, so to say. No company around the world, at least not if they reach a certain size, can afford to ignore the internet, the World Wide Web, and the same will hold true for what AI has to hold for us. Before I get to the topics themselves, a quick introduction of what we do. We are the Python Quants, a company I founded a couple of years ago, so not really a startup anymore time-wise. We focus these days on training, mostly online training offerings with regard to Python for finance, with regard to Python for algorithmic trading, and a few other topics. But we're also organizing and co-organizing, taking part in events, and mostly in the financial capitals, due to our focus in London and in New York, Manhattan. I've published 3 books. I will show you the covers shortly. We run a platform called Quant Platform. The URL is pqp.io. I have a separate slide where we have more than 10,000 registered people working on it. And of course, we are active in the open source field. We have open source financial analytics library with which you can do quite sophisticated financial analysis with regard to option portfolios and risk managing such portfolios. Our platform is intended to provide within the browser all the data science, all the analytical capabilities that you might be looking for. We use it also heavily for the training, so all the contents of our trainings like recordings, etc. are provided there. So it's growing not only in terms of the number of people, but also in terms of what we do there. So if you go to PQP, you can register for free. The individual accounts are for free, and we try at least to keep this for the longer term in this regard. If you're interested in what I'm talking about beyond the conference here, go to my private website, hilpisch.com, find a wealth of information there, many talks, more than 100 talks with slide decks, with GitHub repos, with gists, with videos, and much more. So feel free to visit the page and to look what might be of interest to what you are doing. Here are my 3 books. I think the most popular one is the one in the middle. Not only that I think I know it, it's the Python for Finance with O'Reilly. I just recently signed a contract to write the 2nd edition over the winter time. So mid next year, there should be a 2nd edition out. The print version here is from 2014, December. So many things have happened since then. Our ecosystem is evolving fast, and we'll try with the 2nd edition to keep up with all the fantastic developments in the Python space when it comes out next year. At the beginning of the year, we came out with our university certificate in Python for algorithmic trading, really popular, and I know that here in India, trading algorithmic trading is a really popular field. We have many students also from India, so I'm really happy about that. And I have provided here a special which is a 50% discount, and it's the cheapest we ever offered, our core course here. And I've seen already a few sign-ups in my inbox, so some of the people who attended yesterday's session, they have made already use of the discount, which will be valid for only a limited period of time in this regard. So if you are working in the field, if you're interested in our core course, feel free either to reach out or to use the link that I provide here, hitpi.tpq.io. I'm also really happy that after so many years working in the field, other people recognize us. So we've been awarded a Banking Analytics Award at the beginning of the year. Also another one, which is more a technical one, 50 best companies to watch. So once you're included in these lists, then the phone rings, or rather these days you get emails from venture capitalists and from others who might be interested in working with you. So really exciting times. And back then, more than 10 years ago, when we started using Python for finance, people didn't really believe that Python might play such a role in the field that it plays today. But I'm more than happy that it turned out. So it might have gone wrong, you know, if you're an entrepreneur, if you bet on something. There is nobody around the corner who gives you a guarantee that your plans will fulfill themselves. But as far as I can tell, Python now is one of the major technological forces in our industry, in the financial industry. I'm also more than happy that we can work with strong partners, without which most of the things that we do with regard to events in particular wouldn't be possible. So Thomson Reuters, a great thank you that they host regularly our meetup group in London, which is the Python for Quant Finance meetup group. We have 2,300 people in the group, usually 100 people in attendance, all more or less finance professionals, and I think London is a particular good place to do this. So thanks to Thomson Reuters for hosting us there. Fitch Learning, CQF Institute, also one of our strategic partners with which we do our For Python Quants bootcamp series, which goes over 4 days, both in Manhattan as well as in London. London will be later in the year, at the end of November. The Manhattan one was at the beginning of the year. Actually, in May it was. So really grateful also for the cooperation with our local university, the HTWSR, which allows us to grant the university certificates for our, let's say, bigger online training programs. Let's get to the topic of today. What might artificial intelligence do to finance? A bit of background. This is a slide I've been using since quite a while. A couple of mega trends that influence what we do in particular, but I think these trends influence what other people do as well. So here on the software side, it all started with open source in that sense. But it didn't stop there. So back in the days, it was more or less that you saw something commercial and somebody says, well, I will invest time there and I will come up with something that competes with the commercial solution and which might one day be as good as the commercial one. So this has been kind of a typical, let's say, vision or mission of those working in open source software. Now we have it the other way around, that in the open source space you get the cutting edge versions of everything that is out there. So it's not that you say, well, there's this mega professional thing, this costs kind of a gazillion US dollar. No, it's the other way around. Google has open sourced, for example, the deep learning library, and the organizers, at least yesterday, they had the Tensorflow logo on the shirt. So we have access via the open source community to fantastic tools these days. But not only the tools, I mean, the tools are the one thing, the packages, the Python packages, for example. You need hardware as well. In particular, if you want to do something where you might need compute power beyond the notebook that you have on your desk that you carry around, or the desktop that you have under your desk. And in this regard, we have also seen fantastic developments with regard to open infrastructure, where you can more or less get compute power, storage, etc., all that is related to the infrastructure, more or less like from a plug, like electricity, like a commodity. You say, well, I need 12 cores and 16 gigs of RAM, and you get it within a minute. And not kind of like writing a contract, signing it, you know, going back and forth, and well, let's wait for 4 weeks, and you know, this is how it used to be, but now you simply log in, and speaking of the infrastructure, I don't know what happened for whatever reason. It changed here. So I think I might go back for a second because the recording stopped for whatever reason. I don't know. Maybe there was something with the projector which sent the wrong signal. Let me quickly save this because I was asked to record this as well. Sorry for this little delay here. 5 more seconds, we should be good to go. Sorry about that. This is one of the reasons why I always tell people when they attend our trainings that they should take care of when they do algorithmic trading, that they do it on an infrastructure that is high availability, because these things that now happen here, they might happen also with your trading machine back home. You know, something is happening and you don't even notice. You know, in the back end, it seems kind of okay, but things happen and you don't even notice. Then you might lose money, in particular when we talk about algorithmic trading. So to have kind of a proper infrastructure that is readily available, and not readily, but also available on a high availability basis is kind of nice. But we are moving here also towards specialized hardware. So when speaking of TensorFlow for deep learning, for example, recently, I think it was kind of like 2 months ago, Google announced the Google.ai initiative, where they will provide dedicated data centers to be used for deep learning initiatives, for deep learning applications. What they apply there is kind of dedicated hardware in a sense that they use what is called TPUs, tensor processing units. It's similar to the development that we have seen in the Bitcoin space. Actually, where it all started on a CPU for Bitcoin mining, then they moved to the GPU for Bitcoin mining, then they use the FPGAs. They are more configurable and they have been faster than GPUs. And last but not least, we then got the ASICs, the application-specific integrated circuits, so chips that are specifically designed to do what they are supposed to do. And of course, specialized hardware typically is much, much faster. And this is what we see here, and I expect here exponential growth, more on that later on. But data is kind of, at least in our field, and the accessibility, the availability of data, at least on a professional level, I think is what will be driving most of the things that I will talk about in this regard. So more on that later on in some detail, also with regard to PyConf from Thomson Reuters. Social networks, I really enjoy to be involved in the community things. Here we are at a very nice first time conference in Hyderabad. The Meetup platform has established itself as kind of the go-to solution to organize meetups, but there are also specialized events. So speaking of my field, there are now, not only from us, but also from others, kind of specialized events which make it more worthwhile to attend for, like, let's say, professionals that are not only interested in Python in a general sense, but they want to apply it in the daily work, and this is usually an easier sell for or to your boss in this regard. Machine and deep learning, as well as algorithmic trading, have many, many things in common. I used the slide in the workshop as well. So, of course, we are dealing with data, algorithms, and hardware, or you could say data, software, and hardware. The core part in both areas is something with regard to optimization. You train models, you have learning procedures that you apply, and then you test them, you validate them. These are all steps that we have basically seen more or less completely in the workshop yesterday. Where OLS, for example, is an optimization step. Then we trained the model, we tested it. Actually, the validation was not that pronounced there, but in principle, we went through all the steps there in the workshop. The goal being in the algorithmic trading space that you have a money-making machine that makes money on its own. So this is kind of the holy grail in our field. You know, you simply say start or play or whatever, go trading, and it makes money. At the end of the day, you get back home and you have a look at your account and you see that it has swollen. The problem itself is not too dissimilar to the self-driving car story, you know. You don't want to have your hands on the wheel anymore. You want to have the machine drive the car. So the thing is automation, and this is what we are all after, no matter what field, and we'll see much more automation in many, many other fields there as well. When we speak of algorithmic trading, finance, this is kind of a pyramid that I regularly use, starting with the infrastructure, which is important. Of course, we need the data. Data is the basis for everything, be it historical data, structured, unstructured data, be it real-time data. So this is what we need, and on top of that, we can only do the coding with regard to strategies, backtesting, connect to the platforms, trading code that we need, let's say place a buy order, place a sell order, and last but not least, do the automation that may be in or based on a cloud instance with some of the providers. The benchmark case of random walk, so this is what we fight against, and also in the workshop, so I can refer you to the resources there once again. We did this with a little Python exercise where we basically, I wouldn't say have proven the random walk hypothesis, but we have shown what people usually meant in this regard. Here is a quote, which is already from 1965, which says basically that if the random walk hypothesis is true, then many of the efforts that we see in financial markets might be completely pointless and worthless. So this is always a story about active management of portfolios and funds versus passive management. So does it make sense that people sit down and analyze piles of data to come up with some idea that might outperform a benchmark? You can answer it for yourself, or you can research it for yourself. If it would be true, then it would in principle be pointless to do some kind of analysis. Here is a quote a few years later, more than a decade later. Market is efficient with respect to an information set S if it is impossible to make economic profits by trading on the basis of information set S. So it's a little bit more formal. You see the whole field of finance has evolved to become more and more formal over time. Today it's a purely applied mathematical discipline. So this is what we see now. So translated to our story, using Python, AI, and so forth, this means that if you get your hands on a data set, no matter of what type, no matter how large, no matter how granular, no matter what quality of data is stored in it, if the markets are efficient, then there is no point in trying to predict anything there. Then there are people that say, well, they might be efficient, but temporarily they are inefficient. So temporarily we might spot kind of inconsistencies and so forth. But I would also argue that we today have, of course, if you have a look, 65, 78, today we have much more sophisticated and powerful tools available. Open source, TensorFlow, open infrastructure, specialized infrastructure, with which there might be something in it that wouldn't have been ever possible with all the power back then in the 70s to discover. So I'm still really hopeful that there will be many fruitful applications in our field. So if a stock price follows a simple random walk, this is just like the translation of the concept, then it rises and falls with the same probability of 50%. This is like going to the casino and playing just red or black. So 50-50, so ignoring the green 0, 50-50, and if the markets are like this, then we get as a corollary, so to say, in such a case, the best predictor of tomorrow's stock price in a least square sense is today's stock price. So you wouldn't trade at all. You simply you would sit on your stocks. And this is the benchmark against which we are going when we try to apply AI in finance, in particular to algorithmic trading. And once again, in the workshop, we tried it a little bit based on Jupyter Notebook, using pandas, using scikit-learn, using ordinarily scarce regression first, and then moving on towards a classification algorithm, logistic regression. And we saw some kind of decent results there. I'm not saying that you should now go and immediately implement them, but at least there might be a little bit more in it than might have been foreseen a few decades ago. Who has ever heard of the technological singularity? Nobody. One in the back. Oh, sorry, I was kind of like so focused on this side. I'm sorry, I'm a lefty. That's the reason why I'm more on the left-hand side. There are a few, but not everybody. So maybe a little bit of background. Here, technological singularity, one of the most fascinating concepts that are now discussed, and not just since yesterday, since quite a few years. And there are now popular books out there, not kind of research publications, I would say, but books for everybody who has a little bit of a technological background, like the one by Nick Bostrom here, a professor of superintelligence. I've seen it now at that many airports, so it has become really mainstream, like a best-selling book. Singularity Rising, I think, is a little bit easier to understand from my point of view. But if you want to get kind of the mainstream introduction, you should have a look at who recognizes this show there. How's it called? Person of Interest, exactly. And the background of all this is kind of this all-powerful machine in the background who sees everybody, who has access to every single video surveillance device that is around Manhattan, and who has, as far as I understand it, unlimited compute power and so forth, and predicts crime and so forth. Basically, this is what the technological singularity is about. And also in this show, as it progresses, I've seen all the seasons. It more and more becomes conscious and acts on its own. So this is kind of the point where we say, well, now a machine is conscious and decides for itself and does something that was never programmed into it. This is basically what the technological singularity is about. Here is a picture and the link. If you go to the slides, you can watch this video. If you are interested to get started, this is my recommendation. It's a TED Talk, 16 minutes. You get the gist of the complete story by the man himself, Nick Bostrom. So vast increases in biological and machine intelligences will create what's being called the singularity, a threshold of time. So this is what we need to consider. Some say maybe 2045, at which AIs that are at least as smart as humans and or augmented human intelligence, like combining machines with ourselves, radically remake civilization. So others say, well, this is the day when a machine reaches general human level intelligence. This is another term. So there are many, many technical terms that are used there, but I think in principle, most of them are easily understood. And before that, I referred to TensorFlow, deep learning, and to dedicated infrastructure. And I would put all these developments that I was referring before to into this basket of discussion, so to say. This will further fire up what is happening there. So Google AI first was my first quote. They are now coming out with a deep learning data center to which everybody can get access, also probably built by the hour and so forth. So we would see exponential developments in certain fields, and Google has done here the first step, going from commodity hardware towards specialized hardware, which will be much, much faster in training models and using models based on what TensorFlow has to offer. So like DNN classifiers and all the nice things that you find in there. What are the paths to the singularity, to general human level intelligence? One that is intensively discussed is emulation. So I'm a little bit older, so my first computer was a C64. And I used, back in the days, my first language, like for many people, was BASIC back in the days. And then we moved on to assembler because we wanted to control the machine. And that's the reason why I'm using this example, because I'm still kind of a gadget freak. And back home I have, I don't know, 3 Raspberry Pis in my home office and so forth. And today you have this little piece of hardware, Raspberry Pi. I think it runs on every Raspberry Pi model that is available. I don't know whether on the Zero, but at least on the current regular ones. And you can completely emulate what the C64 was doing. Not kind of like simulate, which means there is, let's say, some Python program in the background, like a chatbot, which emulates what the machine is doing, simulates what the machine would be doing. No, it emulates the whole thing with the ROM, with the chipset, and so forth. And then you get the gadgets like the Competition Pro I used to use for gaming, with which you can interact. So the emulation is not kind of within the machine, you can also interact with the machine in the same way. And this is this is my analogy to what people in the singularity space discuss when they talk about the emulation of the human brain. To be able maybe one day to completely emulate what is going on in the brain. So for example, when I add up 2 plus 3, I can come up with my brain, I don't have that much more, maybe using my fingers, I can come up with a 5. But what is happening today when you go to the computer is not that what is happening in the brain is emulated to come up with it. It's done via another algorithm. And this is basically, I would say, currently the most promising path. You know, I'm as a human being, I get an input, 2 plus 3, I can come up with 5, but basically the machine doesn't need to know exactly what I'm doing in my head. The machine just needs to have an algorithm, f of x, which comes up with a solution. And this might be a simple example, as I was using, or it might be a rather complex one. Like recommendation. Back in the days, maybe it was the mother who said, well, I know you like this, maybe you want to buy this, or you like eating this, try this one. Today it's the machine that's doing what our mothers have been doing in the past. You've read this book, maybe you want to try this book. And all these things that we know and that are kind of so common these days. And I think this is where we might go into. Who of you is playing chess on a regular basis? Oh, a few here. Who has ever played chess? Okay, many people. Who knows what chess is? That's the reason why I'm using this, the chess singularity. This is now a little lesson in history. This is not looking forward, because in chess, we have had, I have come up with this term, chess singularity. I've never read it someplace else. And I've defined it as a threshold of time, along the lines of the other definition, for which on chess programs play better chess than any human being. And this is already the case since quite a few years. So here it's a very interesting book, not only if you are a professional, semi-professional, or even amateur chess player, by Garry Kasparov, because it deals with the advances of AI, deep thinking. It came out, I don't know, 4 or 5 months ago. And here you see I've picked out the 3 quotes. I think it's from the intro chapter. And it says, it was a pleasant day in Hamburg, 85. Each of my opponents, all 32 of them, was a computer. And he scored a perfect 32-0. Probably he would have scored it blindfold as well, I don't know, but it's a perfect score, 85. 12 years later only, he was fighting for his life, his chess life at least, here how he writes, against one machine, a $10 million IBM supercomputer nicknamed Deep Blue, and he lost the match. So this is how fast the evolution has been going there. And I only learned in this book, or in the context of the publication of this book, that IBM came up with chess-specific processors. So this machine wasn't based on standard CPUs back at the time. They had hardware teams design chips, and they used 480 of these chips to play chess, just to evaluate positions. It was more or less, he is writing, not reliant on artificial intelligence, but more or less relying on sheer brute compute power, but still, it's a machine that has beaten the world championship. And now, everybody of us, if you don't have, you can simply go to Google Play Store or the Apple Store. You can download an app. I use chess.com, for example. I like the styling. And this is supposed to have 3,000 plus on my iPhone, 3,000 plus ELO points. And the current world champion, Magnus Carlsen, is around 2,830 or whatnot. So even my iPhone is supposed to play better chess than the best person in the world. And this is how far this has come. Due to hardware improvements, of course, due to software improvements and all the things behind that. Did the human race resign and stop playing chess? Well, probably not. I mean, we are still running races. I saw there was one going on around the campus, obviously, although cars are faster than we are. So it's kind of the same thing. If you like running, why shouldn't you run, even if a car is faster, or a bicycle or whatever? So Garry Kasparov, this is the nice part of the story, I think, is that he said, well, there are some consequences out of that, not only for chess, but for other areas as well, that he said, well, you must learn how to modify and to make your own digital tools. So this is what augmented human intelligence, this is a term that we heard before, might mean in this regard. All the prominent and good chess players back then, they started using, almost from the outset, computers, machines, programs to prepare for the tournaments. So this is, of course, a valuable tool. The one thing is to consider that we are competing with some tool, machine, or whatnot. The other thing is to say, well, make use of it. I mean, when people buy Alexa or the new tools from Google or whatnot and put them in their home, I don't think that they have the feeling of competition with that, so I'm smarter than you. Or they try to benefit from what this can explore. And maybe we will be able to explore completely new frontiers, what he's writing here, and explore them as we get better in using the tools and adjusting the tools and make use of the tools. Now, what about financial singularity? Many people already write about the quants run Wall Street now. It's not the traders anymore, you know, you still see them standing on the Chicago Board of Trade or on Wall Street. I remember when it was for the first time in the 90s in Manhattan, I wanted to immediately go to Wall Street and see the people walking around, and later on I attended a dinner there and I was on the floor, you know, it's kind of for me like a fantastic thing growing up and studying finance and so forth. But this is mostly gone. There's still people walking around, but they are not doing anything anymore, really. You know? So they are managing some things, but the quants and the computers, you can say, they run it now. And financial singularity is not a term I came up with. This is something that you can find, for example, on Wikipedia. It is the point at which all investment decisions are made by intelligent machines rather than human agents, when all human fallibility is eliminated from markets, efficient markets, which have only existed so far in theory, could become a reality. This already hints to an issue that I will touch upon later on, what it means if we will face something. The one thing would be, oh well, human fallibility is now out of the equation, the machines have taken over, I just sit there and profit. But maybe it might come worse in this regard than we expect today. Another book, I would consider this probably the best introductory book to the singularity story I have read so far. But even in this general book, the author is referring to algorithmic trading programs that are still relatively simple, make only limited use of AI, and he also says and predicts that this is sure to change. Artificial intelligence is beneficial in any domain where patterns have to be found in large quantities of data, and effective decisions have to be taken on the basis of those patterns, without doubting them and reconsidering, you know, all these kind of emotions and fast calculations. And I think he is right in this regard. So this is for me kind of, although it was written in 2015, we haven't achieved that. And in terms of timing, I will comment later on as well what my take on this is. Just as one example of a company making heavy use of computers and being really successful, just when this article came out, I became aware of this company called Flow Traders. And it's a company that trades per year some 640 billion euro in ETFs and the same amount in futures and other asset classes. So more than 1 trillion turnover has this company. The company only employs, let's say, some 150 people, 140 traders when you read through the text. And when they recently released their results, they showed that 34 months without a single loss month. So 34 months in a row, it's okay. Other people have managed that. But if you read a little bit further, you see that they have a distinctive approach to algorithmic trading. They use many, many things that are deterministic as compared to stochastic approaches popular in the industry. So they're going a different route. They make tiny, tiny profits, tiny margins, but nevertheless, they make margins. And the most remarkable thing in this Bloomberg article is the last red circle, that the company hadn't lost money on a single trading day in the 34 months over which they reported. So on a monthly basis is one thing, but to be, let's say, perfect on a daily basis, this is impressive. So I cannot comment on what kind of algorithms they use and so forth, but what you see is that one general truth in the markets is kind of proven true here once again. It's that if you have something that is deterministic, that is sure, or let's say riskless, you typically earn only tiny returns. And this is what we see here. So on every trade, on average, they make only 0.02.8%, which is almost nothing. For a human being, for a human trader, this would be negligible. He would never go for lunch and say, oh my goodness, this is big trade, you know, but the machine doesn't care. So even there, no emotions. The machine simply goes and collects small, small profits, but on a large scale, more than 1 trillion turnover per year. And I think this is one good example that shows that if you make the right use of the technology that is available, then you can make sure profits. Also algorithms here, probably they crunch lots of data and all these things that I have been commenting on. So in terms of emulation, what would this mean? So if you translate the concepts that I have shown With regard to the paths to singularity, again, my Commodore C64 example, this would basically mean that a machine should be big enough to be able to model and emulate the complete market and all people interacting in the markets. So we have seen already in the context of the technological singularity, it might be a little bit tricky to get even one single brain emulated completely. And now when you want to emulate many agents, like thousands of people interacting in the market and other machines as well, you need to include the non-human agents as well. This might be a little bit too hard of an issue. So a complete market with replication of all agents, so this might be a little bit far away. This is at least my opinion on that. But, and here the algorithms come into play again. Probably one doesn't need to emulate, to remodel everything that's happening there, all the market activity all over the world. It might be enough, this needs to be proven true, to have the proper algorithms applied to the proper data and the signals to be implemented and executed properly to be successful in this regard. And we have learned already there are powerful libraries available, not coming from the financial algorithm space, but from all the machine learning and deep learning areas. There is now special dedicated hardware available, so I'm pretty sure that we would see amazing things there. In the meantime, I agree with Peter Thiel, who has become well known for co-founding PayPal. He's now venture capitalist, one of the first investors of Facebook, and in his popular book, bestseller book 0 to 1, he also touches upon the topic of singularity. He names it a little bit different, but this is what we are discussing here is what he means. And he says that everybody's talking about what computers can do. Even here in the middle quote, he mentions Deep Blue, what I was referring before from the Garry Kasparov book. But he says that there are that many big achievements from complementarity, and this is basically the same conclusion that Garry Kasparov has drawn. We are not supposed to fight the machines in many areas. We're not supposed to try to be better than our iPhone at playing chess. We can use it as a tool to train ourselves, to get lessons and so forth. And we might even be fascinated by what is going on, but the question that we should ask ourselves, how can computers help humans solve hard problems? So we might want to get out of our comfort zone and say, well, I'm used to ask this and that question and go that direction. Maybe I need to get out of this box, out of my comfort zone and ask completely different questions. And one of the good examples is Elon Musk. You know, he's seriously considering flying to the Mars. I mean, I haven't been considering this. You know, I've never had the idea to come up with a startup, but he's doing this. He is not only getting out of the box, out of his comfort zone, he's getting out of the planet in order to achieve what he has in mind. So maybe this is the point where we should ask ourselves, where do we see something that can be done better based on what is now available? Data as a driving force. I have prepared a little real-time, or let's say live demo with regard to data. I mean, this is all where we're coming from. So this started more than a century ago, that stock traders, investors used publications like the Financial Times, in particular the Wall Street Journal in the US, even during the crisis it was around in the 20s there, and you have paper. I also have a paper with me from the hotel this morning, so this is still something that is used. But the question is this still the right way to get your financial news and your financial data digested? And I would say no. And intelligent people and entrepreneurial people like Mr. Bloomberg and others at Thomson Reuters and many other companies have come up with interactive terminals. Here, for example, the new version of the icon based on HTML5 and a modern web interface, and you can search for news for just the stocks that you're interested in. You can Google up all the financial data immediately. You can zoom out, you can zoom in, you get a history, you can everything. So people that do something serious in terms of investing and trading, they don't rely on paper anymore. So they rely on the electronic interface where they get access to the complete world. And now we are moving towards programmable access, and this is what I want to show you. And I think this is one of the major driving forces. When we want to apply the algorithms, the software, to data, we must get access to this data as we are used to in other areas. And when I quickly go back here, this is actually already it. think the recording, either it is recording or not, but let it go there. So here's a little notebook. I don't go into the details of what I'm using here. It's basically Icon, which is a wrapper, and in the background there is some proxy running. I have a local proxy running, which provides me access to the data world, the data lake of Thomson Reuters Icon. This is due to a licensing issue, so that they know that I am the one who is doing it and that it's locally bound. I couldn't do this as it's currently implemented on a server. But let me get started with the imports. And what I want to focus on is how easy it is to retrieve data. There are some public data sources for which you can get similar data, at least similar data to what I show in the beginning. So here you see a single line of Python code, EK for icon, get time series for Microsoft, just a close field, and for some 2 years worth of data, what I'm looking for. So executing this, if the connection works, and you see I immediately have my data in here. This is already different to working with a web interface or kind of an application. With the application I can go there, I can zoom in, can zoom out, but nevertheless I don't get my hands on the numerical version of the data. I usually have it visualized, or in the application I have kind of a table. Here I have a single line of code and I have a data frame. And we are here at the Python conference, and I'm pretty sure that almost everybody knows what to do with data in a data frame. For example, we can create a nice interactive plot. Now I have plotted this with cufflinks. See, there's a best fit line in there, and the data is plotted. As simple as that. 2 lines of code only. I've retrieved the data, and I have created my own plot. I can retrieve data for 2 companies. Not for 2 companies, sorry, for 2 rigs as they call it. It's 1 company and 1 index. It's still Microsoft and the S&P 500. I can normalize the data and show you the relative performance over the time period we are covering here. In the beginning it was kind of a mixed performance of Microsoft, but then you see both in the upper chart, orange above blue, and green means that the one that we started with is kind of outperforming. So Microsoft has outperformed the S&P 500. So would have been a better investment at least over these 2 years. Not speaking of any investment advice, but these are simple analysis things that we can do. And whenever we get new students and start working with data, one of the first questions I get asked during such a session when we cover data is, where do I get this data now as minute bars or intraday, 1 hour bars and so forth? Many data sources, open data sources that are there that are fantastic, like Quantum, for example. They provide you end-of-day data, but usually you hardly get any intraday data. With the professional subscription-based services, it's the same thing. I simply say, well, here for 4 different names, the 4 technology companies, the field close I'm interested in, the time frame that I've defined here, and I want to get minute data. So for a single day, I get minute bars here. Same thing, I have my data now for 4. I can plot all the 4 of them with the relative performance. So you see this is now over a single trading day only. Don't confuse this with the 2 years from before. So over 2 years this chart might look completely different. I can do some calculations and I can come up, for example, with 4 histograms for every single name respectively, which shows the frequency distribution of the log returns. As simple as that. You see, this is a completely new way, from my point of view, of interacting, efficiently interacting with financial data. And you can get more granular. So the next step, and the lowest one, would be to have tick data. The lowest level, every single tick, every single trade that is done, and get here as well. So I'm asking here for data just for half an hour, 6th of October, so last Friday. Half an hour data, we get 4,664 rows with value data. So you see here we get to the lowest granularity or highest, depending on your perspective, data that you can just think of. But this is not only constrained to the data, this is just to illustrate that how you can interact with financial data. And of course, everybody who is active in AI or machine learning now knows what to do. Applying, for example, the stuff that we have been applying yesterday to our euro-US dollar exchange rate time series. So we can now work with all the different things that we have available here on any kind of time scale that we're interested in. But we can also get the news. You might say, well, this is just about kind of the stock price section of the the Financial Times or the Wall Street Journal. But what about the news? I'm interested in what this guy is saying, what this company is doing, how the Wall Street Journal comments on the new Apple release and so forth. So you can also read news in a technical sense. Of course, if you want to understand it, you will want to read it on your own. And here I have taken a current example, GST and Jet Lay. I don't know how to pronounce the name correctly. And I'm interested in the last 5 things, and I think we get here with the exact timestamp, we get we would get more than 5. I just constrained it to 5 different news articles which went over Thomson Reuters terminal. So I have access also to unstructured data. If I'm now interested in a single story, I'm picking out here randomly the first one, I can also get access here in IPython Notebook to the complete text of what has been released there. And now we can apply things like natural language processing and so forth. We can learn, we can include in our algorithmic trading and everything that we want to do, we can include unstructured text. And I think Python is a wonderful tool to do both. Using pandas for the, let's say, structured world, in memory using NLTK or other packages to do kind of the text parsing and so forth. And you can combine it in a single environment, let's say, in a single application with a single language, single platform. And for those who are in finance, this is just a quick outlook here in terms of charting, what Python can do these days. This is now with Apple data, and you see when I zoom in, this really visualizes now open, high, low, close. So this is a quant figure specifically designed to be good at quantitative figures. We can, for example, add volume by simply calling a method there, and we see a subchart. We can add simple moving averages, something we have used in the workshop as well. And we see them. I can add Bollinger Bands so that I end up here with a nice chart. I can also here, for example, click on something and now what is this doing? And it vanishes exactly. You can get rid of the, just by clicking, of all the single studies that I have added, and you see how easy it is to visualize the data. This, of course, has not that much to do. There's also RSI that I've added, the popular indicator. This has nothing to do with AI. I just wanted to show you how easy it is to interact with financial data and how good our tools in the Python ecosystem are to visualize financial data. From my point of view, this is the driving force. How do we get access to the data lakes, the financial data lakes out there? And Python, you see here, is a first-class citizen, at least in the Thomson Reuters icon world. This is the main wrapper library to get access to it. And what do we have? I'm fine. Yeah. And this brings me with these comments about Python and how far it has come in the financial world and how we can easily interact with Python with financial data to the outlook. A few slides left. So the question is, if AI gets hold of finance and if some people or one guy or a company is able to make proper use and to consistently benefit from what AI is providing, what might be the outcome? So there are a couple of things that are discussed in the literature, but not only with regard to singularity and technology. This is kind of, let's say, good old economic theory. What we can end up with is something like a monopoly. Think of Google. Google search is something like monopoly. Who uses Bing? I don't know anybody who uses Bing. Not bashing them, but it's kind of, it has become part of dictionaries. You know, Googling to Google is these days a verb actually. So, and this was Deep Blue back in the days. So back in the days, it was only Deep Blue who was that powerful that it could be the world chess champion, the human world chess champion. So this is what we saw with regard to chess, 1997, and this was the complete pie, so to say, the economic pie, I mean here, in the sense that this was the only machine who got the recognition worldwide for winning against. Another outcome might be that you see oligopoly, so that a few institutions, a few groups, a few people might be able to get to a point where they make decent profits out of that. For example, in the Bitcoin mining space, you see this. You have these Bitcoin mining pools, a few of them, but this is already moving to monopoly, and someday we will be beyond 50% of one single thing and so forth. I think the hedge fund industry is similar. We have a few big players, the smaller ones that get founded, and they vanish faster than they get founded. So in the hedge fund industry, from my point of view, is similar. So they all get a piece of the pie. 6, 16, maybe 27, but not 2,600 who benefit in the same way. Or we will end up with something perfect competition, where we say, well, you don't need to train to beat your iPhone anymore. You know, every iPhone is better. All what people have been doing over the last 5 years with regard to artificial intelligence and finance can now be done on my iPhone or whatever you're using. So this might also be an outcome, and in this regard, there might only be the crumbs left of the pie. So not that much. I'm not really sure how this might go. I think time plays an important role. What the outcome is, and here is just from yesterday, Bloomberg, the race to AI utilization in finance is a marathon, not a sprint. So it will take a while. You might read through it. I can provide the link if you like. This is very current. Many people see that there is lots in it, but the question is how to make the best out of it. And the issue here is that we have exponential forces at work, which means it's just an exponential function from 0 going to 3 or what. Just wanted to illustrate here that the marathon is the thing to get to 1, to 2.7. From then on, you will have accelerating returns. We will have exponential forces at work, and you will read exponential technology, exponential forces if you Google Singularity up in many places. And this will lead to certain things. On the one hand, technology improvements, so you have more money, you can improve technology, the better technology will make more money, and so forth. You have capital accumulation. The first to get to this point, to reach it, we say, well, now we are doing on a consistent level, we are doing lots of cash, and they will accumulate the cash. All the other people will bring their cash and say, well, please manage my money. You obviously seem to have found the holy grail. And last but not least, and this is also something seen in the industry, the big ones also get the best talent because they have the resources, they are attractive, they are successful, and who wants to work for some little shop who is not that successful, you know? And talent accumulation really is important because beyond all the machines, remember machine plus man or men even, or women, man in the sense of our species, is probably the best combination. So exponential forces are at work and there's a race going on. Even if it's a marathon, probably those who will be through the finishing line first might benefit most because they will be beyond the point where they then will benefit from exponential forces. I myself am a strong believer in that most of the things, not only in the financial field, but also with regard to technological singularity will come. There are many doubters there. There are some people like Elon Musk that say, well, we must take care of that nothing bad is happening due to these technologies. Mark Zuckerberg says, well, don't be afraid. This is all and only good for us. I don't know who I would rather believe in this regard. I think, of course, in every case, we should be careful in every area. But in the financial space, I think alone from a technological and intellectual point of view, it's one of the most fascinating areas. I already enjoyed the last 10 years with Python in finance. I think finance still absolutely intellectually stimulating. Python is a wonderful environment to do finance. And when we now add to the mix this AI in finance, you see here the logo for something that we are up to, then it will be kind of a very interesting future that we are up for. Thank you.
The guys are open for questions.
If you might pick the mic.
A couple of questions. The first one is, how are you going to use AI in insurance sector?
It's a good question. I used to work in the insurance industry in Germany as a management consultant for over 10 years. I have many ideas, and I see this area particularly prone to kind of misuse of data, of personal data, and so forth. I mean, this whole discussion about technological singularity and what might be on the horizon also in general includes topics like genome sequencing and so forth. So of course I can imagine that health insurers would like to have complete information about your health, your genome, your history, the history of your parents and whatnot. And based on this almost complete information from the point of view of an health insurer in this case, again, I think there are more questions on a moral level to be answered than to say, well, of course, it's a no-brainer that if the company has complete information in this regard, they can say, well, yes, I'm happily putting out a policy for you, or say, no, I'm so sorry, this time not.
Or like keep it the other way. I mean, why hasn't the AI picked up in insurance sector? I mean, if you see for the last at least 3 decades, the insurance sector hasn't actually gone into the same revolution as banking or other sectors.
Yeah, I would say in the banking sector neither. So you have a couple of areas, for example, in retail credit, where credit decisions given on the information that you make is a classification problem. Does this guy gets the credit or not, or the family gets the credit or not? They are made in split seconds. So when you go on a website, you put in your data, then it takes, usually they really slow down the process in order to not come up with something quick, because people, this is what they found out, think this must be fake, you know. The machine cannot be that fast in deciding whether I'm worthy credit or not. So the insurance industry, since I've been working there, since I still have some contacts in the financial sector, is usually the lagger behind. But I think, mainly due to the nature of the business. You know, life insurance, for example. In Germany, the average life insurance contract is longer than 25 years. You know, you have built in this business a long-term perspective that doesn't require you like an online shop, e-commerce focused company to change things like in a split second. So, but I'm pretty sure this will pick up there as well. Just think of individual premiums for car insurance policies when you agree for a GPS chip and so forth. They use in the back end the same technologies to track what you do, to classify your behavior in traffic. Maybe this won't work here in Hyderabad, but this is what they use there as well. But not in every corner. I agree with you. It's not, let's say, a common topic discussed on every floor of an insurance company building.
Thank you. While you touched on Bitcoin, I mean, what's your thought on blockchain with AI? How disruptive it is going to be?
You mean the importance of blockchain and what role it might play?
Yeah, in AI?
In AI. Yeah, basically, if we start from scratch, more or less, blockchain is an immutable database. So it's a way to store data. And it's for sure not a way to store data efficiently and to retrieve it. From my point of view, there are many, many nice applications where documentation is the primary purpose. I say, well, it's documented that I'm the owner of this art of work, let's say. But in AI, frankly, I've never thought of kind of the real combination of what business models might be there. So I see maybe this on a personal note. So last year I felt that when I was in London and I attended conferences, blockchain was really at the spike of the hype cycle. And this year it's more or less getting back to AI, and blockchain is getting a hold in many different areas. There are good applications, government applications, you know, areas where you don't have registered, for example. I see this overhyped, particularly the Bitcoin exchange rate. If you have followed my Twitter feed, I'm really, not a critic, I'm a skeptic of what is going on there, and the hype might not be justified in every area, but in some areas we will see very, very good applications there.
Thank you.
Hi, Yves. What kind of data does hedge firms look into? Like, apart from price volume data and news, what other kinds of data that presently running firms are looking into and they would like to look into in future?
Basically, in every data set they can get their hands on. So they try satellite pictures, they try weather forecasts for X, Y, Z, they try everything. So They have the capacity, they have the budget, they have the incentive to look in every corner of the world for what is called alpha there. So sources for outperforming a benchmark. And I recently, with a former client of mine and has become a friend of mine, had a chat, and he said, well, he's now working with Asian companies, and they are buying smaller hedge funds, not due to the assets, not due to the team, but to the special data sets that they have collected over time. So this has become so important in the sense of what I try to visualize or to illustrate, that data is the driving force there. You know, the hardware is there, the algorithms are there, they might be improved, both hard and software, but to have the data, this might be the real edge, because I don't think that even the hedge fund think of buying even more specialized machine to be even a little bit faster with regard to the classifier training or whatnot. So I would, as a summary, every data set where they might suspect any insight, any alpha that they can harvest there. And they are willing to pay millions of dollars for what they call alternative data sets. And if you want to look it up, a friend of mine in London, Saeed Amen, he is now a regular visitor at conference of Bloomberg, also Bloomberg TV. He is regularly talking about alternative data in that sense, and he has published a blog about this as well, so you might Google him up.
Hello. So I just want to know from your experience, right? How did you use unstructured data like news or social media? Is it just sentiment or some other feature engineering that you did to predict, forecast the stock prices or in finance, basically?
Frankly, we haven't done that much in this regard, but I have sit in many, many talks from startups, from the big ones like data service providers, and it's usually indeed about sentiment, you know, with regard to, let's say, election or central bank interest rate rises, or everybody's expecting rises these days, not falls anymore. From all ends, you know, it's also kind of even Trump Twitter watchers, you know, so just to focus on what Trump was saying. In the beginning, I think this has stopped a little bit. In the beginning, he was bashing single companies. And once people noticed that after bashing as a company X, they said, well, this was a drop of 5%. If we can figure this out faster than everybody else, you know, we just wait for what Trump is tweeting, and immediately we have an algorithm in the back end who shorts or whatever the strategy then is, what is in there. So I've seen many, many things, but I don't have any insight into how successful these, let's say, amended strategies are. So if you have numerical data and maybe cross-section of data over 500 stocks or whatnot, and you add kind of unstructured data to the mix and have new features for your machine learning algorithm and so forth, nobody, at least to my knowledge, is talking about the success they had by doing it. So everything I saw is kind of public talks, speeches, you know, we did this, like myself, you know, this goes well, but when people have skin in the game, this might look a little bit different because they now are in the real world out there. But for sure, there might be benefits on it. Not revolutionary, but evolutionary. There's a question up there, I think.
Sorry guys, we're running out of time. You can connect with him like offline or something. Sorry. Thanks, Yves. Thank you so much for your keynote presentation.
Thank you once again for having me.
Yes, sir. Thank you guys.